This was supposed to be the first speaker of this session, Subhamita Chaudhuri, who is from the Department of Geography, West Bengal State University, Kolkata in India. And the screen is coming up. So if you could just make that full screen. So investigating the characteristics of Quaternary beach rock and its implication on geomorphic evolution of a mesotidal bay, a case study, pardon, that suddenly jumped, Shrivardhan in northern Konkan coast, India. So please go ahead.
Okay, thank you. Thank you all. I'm really sorry for the technical problem that happened with my microphone. I'm grateful to the Hellenic Committee for Geomorphology and Environment and IAG for giving me this opportunity to present my paper on beach rocks as a geomorphic marker of sea level variation. It's not changing.
Sometimes if you actually click on the PowerPoint itself and then click forward,
it's okay. So if we see all along the Konkan coast of Maharashtra, that is the western coast of India, we find various locations where we find the beach rocks. Now, even if we see in the rocky headlands or promontories along this coast, then we will see that there are multiple evidences of multiple notches, high-level platforms, which are about 5 to 6 meters above the present coastline. Now, though there are many locations where beach rock has been reported along this coast, but this small bay of which I am going to talk about is called Shrivardhan, and nobody ever reported that there was presence of beach rock here, possibly because that this area was not totally a reclaimed area, and there is active marine processes operating here. So we find that beach rocks can be seen at various geomorphic settings where we can see that somewhere it is lying unconformably on the basaltic platform exposed, and it is just adjoining the present coastline. Somewhere it is like a lithified bar which has a thin soil cover almost 2 kilometers away from the coast, or somewhere it is a lithified spit-like formation. But all these locations are here marked somewhere in these yellow portions in the map. These are the areas which are below 20 meters of altitude, and these now appear as reclaimed bays or tidal estuarine areas. Now I'm talking about this small mesotidal bay, that is Shrivardhan. As you can see that there is water inside, and the bay is not reclaimed like the other areas. So this is a false color composite of the area, and this bay has a very prominent bay mouth bar which is blocking the mouth of the bay, which is almost turned into a lagoon. Now the samples that we came across, those were collected from the this portion of northern part of the spit which adjoins the northern headland, and here are some samples which were collected inside the lagoon. There is the island which you can see not a very stable one. Some portions are now stabilized due to thick mangrove growth, but there is one portion of the island which is now covered by terrestrial vegetation, and the samples were collected from this core part of the island. So if I just blow it up, then this is the core island among the surrounding mud flats, and these are the two well sections where we found these samples. On the northern side, here we have the sample locations. Here also these are well sections which we could study. Now the simple methodology was that first we tried to determine the relative height of all these exposures from the present day highest high tide level, and we also collected samples for microscopic analysis for carbonate petrography. Now, after we analyzed the framework constituent of these samples, we found that there were skeletal grains, mostly of benthic foraminifera, and of course some gastropods, bivalves, etc. There were some non-skeletal grains also, like peloids, mineral grains, algal fragments. There were intraclasts, because this is mostly a basaltic area and we have few lateritic capped hills. So we have mostly basalt and laterite as intraclasts. The cement which binds these littoral concrete is variable. It varies from low magnesium calcite to high magnesium calcite and also to aragonite. Sometimes we find microcrystalline micrite also. So the well 1 and 2 that is in the island, these fall into the group 1 type of carbonate rock as per Folks classification. And the other samples that were collected from adjoining the northern headlands, they were seen clustered in this part. So they are mostly sparry carbonates. In some cases, we have micrite in high proportion. Now these are the island samples which we could plot. Of course, there is a problem because the wells in which we see these samples, they cannot be approached because of the water we find inside. So we could approach up to the water level, and we have tried to correlate it with the present high water line. So here in the two wells that we found, there is a substantial amount thickness of overburden, and these are some terrestrial material on which we have absolutely different type of vegetation growing, terrestrial vegetation. We have lots of peloids, and the grain size is also very fine. The forum size is also very, very fine. These were mostly seen as parallelly bedded. Here in the upper part of the first well, we also found some of the bioclasts, the bivalves. They were silicicized instead, or they were changed from carbonate cement to silica cement, maybe in the later sequence of diagenesis, when this area came under the meteoric diagenetic process. But in general, what we found in the lower layers of both the wells is there are a lot of aragonite crystals, as we can see, the needle-like aragonite crystals, and these are actually unstable, and aragonite crystals can change into other types of spirite, calcite crystals. But here we see that still there are aragonites occurring in these samples. In this case, we have this tooth-like crystals which are indicating the high magnesium calcites which are found in high energy environment together with lot of bioclasts. Now these are the three wells that we could we could sample, which are adjoining the northern headland of the Shrivardhan Bay. This is the largest exposure that we could find. And here there are three distinct layers. We have the top layer where there is unconsolidated soil, and then we have a inclined bedding in the middle layer, which is dipping almost at an angle of 25 degrees towards the sea. And the bottom part showed here in enlarged way. These are truncated trough beddings, cross beddings, which are usually we find in the intertidal zone. So here what we see is the forams. They are much larger in size. The grain size is also much larger than that we found in the island. Here what we see is that the cement is mostly sperrite and micrite, unlike the high magnesium calcite and aragonites that we found in the island samples. So these are the thin section, some of the snaps taken from the microscope. And these are the island samples I'm showing first, which are showing very prominent aragonite crystals and some evidences of neomorphism where the previous high magnesium calcite crystals, small crystals, those are now recrystallizing into sperrites, large crystals. And here what we see is that all around the bivalve portion, there is isopachous rim of high magnesium calcite, which itself gives the indication that these rocks were diagonized in the phrenic zone, not in the vadose zone. But in the samples of the northern headland, the microscopic snaps that I have got here. Here we see that there are large brachiopod cells. There is micritic cement, mostly found in low energy environment. Here also we see isopachous crystals all around this intraclast. And here there is a large foraminifera, and here the aragonite, which were previously here, has now recrystallized into neomorphic calcite. So these are much more coarser. They have lots of pore spaces. All the rocks are of low compaction. Now, comparing these two sample sites, we could come up with a hypothetical assessment of the diagenetic environment. Now, first, let me come to the diagenetic environment of the island. Now, depending on the signatures of the cement, the type of foram, the grain size, etc., we tried to see that in what environment they were diagonized. So this can be the previous situation. This is the present high water level, and the past high water level was about 6 meters higher than what we have today. So this entire top part of the island where we find the well sections, it was totally in the intertidal zone. We don't find any supratidal zone, hence the freshwater vadose zone was generally lacking, and the freshwater phrenic zone was also not there. So here we found that most of the signatures of the diagenetic environment were of the marine vadose, marine phrenic, and the mixing zone. But then now the condition is the water level has come down to here, and now this top portion has come under the freshwater vadose zone, which is now drained by rainwater also. But the cements, they are now getting recrystallized. The marine signatures are now being replaced by freshwater cementing signatures. Now coming to the diagenetic environment in the adjoining northern headland. Now here, this is the present high water line. In the past, it was around 6 meters higher than this, because we found out the height of all the exposures carefully measured by total station from the present high water line. So here what we can find out from the cement and the various diagenetic signatures, that these samples were there in the freshwater vadose in the top part, but in the bottom portion of the well, they were in the phoretic zone. And they were also, influenced by the mixing zone of the marine and the freshwater diagenetic zones. But now the water level has gone down. This is the present high water level, and now only in exceptional tidal conditions or in the rainy months we can have the water going up to the base of the well. Otherwise we don't find much of tidal incursion into this area. And so now this entire area, all the deposits, they have now shifted to the freshwater vadose zone. And we can see the signatures of vadose diagenesis, where some of the bioclasts are having meniscus cement instead of isopachous ones. And so keeping all these things in our mind, we know some of the facts which were already established, and some we have found out from our study, that the beach rock formation in this area varies from about 2 to 6 meters elevation from the present datum and present high water line. These were mostly deposited in the high energy marine phoretic zone, and there is an overburden of terrestrial material. Now from these we can infer some of the inferences, though I must confess that we didn't go for any dating of these rocks. There are some reported dates, not of this area, but surrounding areas, where the dates vary from 3 to 6,000 years before present. But here what we can see is that the sea level was about 5 to 6 meters higher than now. And when the sea level receded, the streams that are draining into the bay, they must have extended their courses to deposit the terrestrial sediment in the island and also in adjoining the northern headland. And simultaneously with the recession of the sea level, the big prominent bar that we saw at the mouth of the bay, that also started extending. And so the water line was pushed further towards the sea. So the island samples may be younger because they still have evidences of marine phoretic diagenesis, and the aragonite crystals are still there. And maybe these areas did not get enough time for complete replacement of the aragonite by calcite, so not enough time for neomorphism. Whereas in the northern samples we find that here the calcites are well formed, and so they must have been older deposits than the earlier island ones. And we also find a very clear distinction in the size of the forams and the constituent grain size. So that can be due to the function of the sorting mechanism, because the islands are at a greater distance from the coast than the northern headland samples. So it can be due to the sorting mechanism, or maybe because of the encircled lagoonal environment. The material that were deposited were of a different size. So I end my presentation here.
Thank you very much. That we have a few minutes for some questions. I believe there was one in the chat. I don't know if the person who wrote that would like to actually ask it themselves.
Well, Subhamita, can
Yes.
you hear me? Yeah?
Yes, ma'am.
I have a question.
Yes.
It seems that the variation of sea level are important. So I would like to know whether what would happen in this in the conditions of climate change and elevation of the sea level that is reported. What do you think about that?
Yes, it is now a very pertinent question that is coming up all over the world. But the coast that I was talking about, as we know that sea levels are very much relative, and we do not have a global trend as such. So there are some evidences in this coast where instead of a rising sea level, we find evidences of falling sea level. And that is recorded both in the rocky headlands and also in the depositional setups that I just talked about. In the eastern coast where I belong, in the Bengal coast, these areas are of course more vulnerable to sea level changes, as you just mentioned. But I think that there are many studies which have come up with which are showing a number of evidences where there has been remarkable erosion of some of the deltaic islands in the eastern coast of India, that is in the like the Ganga Brahmaputra delta area, the islands adjoining that delta. But what I have found is that yes, the sea level trend is rising, that's true, but the rate of erosion that we often correlate with sea level rise, that should not be done in a very linear fashion in case of a complex environment like the delta, because so many factors are working together, complex currents. There are very intricate bathymetric changes which are going on. So it is not so simple that wherever we find erosion, we will say that it is due to sea level rise.
Yeah. Okay. Well, thank you very much, and I did really appreciated your very good presentation. Thanks.
Yeah. Thanks. We won't have any time for any more questions, but you have two more questions actually in the chat for you. So
yes.
Please, if you write the responses to those in the chat while we go on to the next speaker.
Yes.